Welcome back. So we're going to pick back up where we left off in lecture 2-1. And in this lecture, let's talk about access to the data itself. Now, at the end of the last video, I talked about the example of giving somebody the key to my storage unit. All right. Now, if I give somebody the key to my storage unit, what can they do? Can they take things out of what's in my storage unit? Can they destroy the things that are in there? Absolutely. They've got the key and they can access it when I'm not there. We'll call that mutable. Now, let's say that the example they use in the text, that something's being stored in a plastic box. And it's one of those bulletproof plastic boxes. I think I saw something the other day where somebody had a hard disk and it was their latest release of music was stored on the hard drive. And people were beating this plastic case that surrounded it to try to access it, and they were beating it with a hammer to try and get into it, but the case was hammer-proof, if you will. So that's something that is immutable. You can't access what's in there to modify it. All right. Now, that doesn't mean you don't have the ability to see what's in there in this context. What it means is if it's immutable, it's sealed, you can see what's in there, you can see the value in it, but you cannot change it. Okay. So you can see that hard drive in there, the example that I gave, but you can't change the fact that the hard drive's there or not. Now, if something is mutable, that was the example I gave, somebody can go in and modify it. Now, let's say that I want something to be constant. It does not change. Well, we're going to assume that is mutable, or immutable, meaning you cannot change it, within the execution of the code. So, if I wrote a program that asked the user to enter a value, and I want to divide that value in half, divide it by 2. The number 2 is constant. So that value that I'm going to divide by is a constant value. Doesn't change. I'm going to divide, every time I run this program, I'm going to divide by 2. So that value is a constant. What the user inputs is a variable. It's immutable. Okay? Every time I run the code, something different is being stored in there. Doesn't change. And it can be changed every time we go through this program. Now, does that mean that that constant has to stay 2 for forever? No. I could rewrite that program and modify it to put the value 3 in there so that every time we run that code moving forward, it's divided by 3. Now there's 2 ways to look at this. I could just have the number 2 in there or have the number 3 in the calculation and go that way. Or I could use the constant with a value of 2 in it and then just refer to that storage location with the named constant and go that route. And I would prefer you to go that route rather than using just the number in your calculation. And there's a reason behind it, and the reason is you may use that constant more than once in your code. And if that's the case, if you decide to modify your code and instead of it being the number 2, you want it to be the number 7 in that constant. Well, if it is a constant, you just change the value of what's stored in that constant rather than changing every line of code that used that number. Now, we've got 2 ways to deal with data. One is literal and one is variable. Now, they talk about literal as it's a constant. Variable, it can change over time. Now, we're fairly familiar with what things being variable means, that it changes over time, and think about our age. Our age is variable. It's not fixed or static. Okay. There are a number of reserved words that we cannot use in our program when we name our variables or when we name our constants. The name is kind of like the alias to where these things are being stored. Words like false, true, from, global, and capitalization is a big deal. We'll talk about it more as we move forward. But here's a list of reserved keywords. And that's something that we'll talk more about it as we go through the course. But some things that we don't do and things we can do. Some things we don't do. We don't start the names of variables or constants with a number. We don't use special characters in the name like an exclamation point. That has a special value to it. We can't use an exclamation point. We can't put a dash, which some may call a subtraction symbol or a minus symbol. We can't use that in naming. That's a numeric operator. We don't put spaces in names because a space has a value. It's a character of sorts. Constants, we will have the first character in the name of a constant as an uppercase character, and variables, the first character is traditionally, for what we're doing, a lowercase character. Now, that's not to say that we would be prohibited from using the underscore. That means, in much programming, that means something different. So for what we're going to do at this point, variables will start with lowercase. Constants will not only start with uppercase, but all of the letters will be uppercase. And there's something that I'll talk about in naming, may talk about it in the next video, but it's what we call camel case. And in camel case, the first character is lowercase, and if the name of the variable contained multiple words, see how we see here another name. Well, we can't put that minus symbol in there, so I could just have another name without the minus symbol. But if I wanted to denote the importance of the fact that it was 2 words, the N can be capitalized, and that would be camel case. Each word within the name would start with an uppercase, with the exception of the first character in the name of the variable. So, if we're going to talk about storing values, storing data, we understand that there are rules that apply to it. I need to have the appropriate space for what it is, space big enough to store it. I need to have space relative to that specific data type. I will give it a name, and that's all done in the declaration of the variable or the constant, the data that I'm going to create space for. So I say, here's what I'm going to store, where I'm going to store it, and there's one aspect that they're talking about here. We say assignment. Now, assignment is what I'm actually putting in that storage space. When I declare a variable, I reserve that space and I give it a name. So I say, here's the type of thing I'm going to store there, and it's not until I use that assignment operator, the equal sign, equal symbol, that I can actually assign something to it. Now I can do declaration and assignment all in the same line of code or in the same statement. So this one is an implicit, and in Python we can do things very implicitly. I implicitly say I'm going to store something in Y, and it's going to have the value of what's in X added together with the number 12. So it's a mathematical operation and an assignment in that one line of code. Now, is that good enough? Do we have to formally declare that beforehand? That's something that we'll get into in the next module when we talk about how we handle the different data acquiring, manipulating, and those kind of things. But at this point, we just know that that symbol, the equal symbol, is an assignment operator in programming. Meaning I'm taking something and I'm assigning a value to some storage location based on whatever we have on the right side of that assignment operator. Now, I don't want you to get used to the word equals in programming. Now, in math, you would say y equals x plus 12. That's a mathematical operation. In programming, we're not looking at this whole thing as a mathematical operation. In programming, only the right side is the mathematical operation. From the equal symbol to the left, that is an assignment operation. Two separate things took place. So when you see that symbol, the equal symbol, that is an assignment operator in programming. And later we'll talk about what's called a comparison operator, which if I said y equals 12, well, that's an assignment of the value 12 to the storage space y. But if I was comparing it, saying is y equivalent to 12, it would be y equals symbol 12. That's a comparison, and we'll talk about that in the future. Okay. Now, we'll talk about what are called exceptions later in the course, but just think that an exception is essentially things did not work the way we wanted them to work within the code, such to the point that the program said, wait a minute, I can't do what you want me to do. And that could be something along the lines of, I asked the user to enter their age and they typed in the word 20, and I then took the word 20 and multiplied it by 2. I can't multiply a word by a number. That's an exception. And that's something we'll dig deep into in chapter 9. Okay. So we still got some more to do, and we'll talk about the different ways to look at programming, the algorithms, what is an algorithm, and I'll deal more with data as we talk about algorithms, but I'll see you in the next video, algorithms, here shortly.